Introduction to fluids. The four common phases or states of matter that are observable in everyday life are solid, liquid, gas, and plasma. In this course, we will not be discussing plasma. Solids maintain a fixed volume and shape, liquids maintain a fixed volume but not shape, and gases can change both. Since gases and liquids both flow, they are collectively called fluids. Open the PhET simulation States of Matter. All right, so here I have states of matter. I'm going to click states, water, and we'll turn it into a gas first. You can see that when water is a gas, also known as steam, the molecules are bouncing off the walls of the container. So here you can see they're everywhere, bouncing around, constantly moving, filling the entire space. When water becomes liquid, the molecules fill the container from the bottom up while moving around. So go to liquid. We can see that this is a cooler temperature. Water is a liquid. It's filling the bottom of the container, but the molecules are still moving around just like this, just jiggling. When water is solid, also known as ice, the molecules are still jiggling around, but are generally stuck in position. So here we'll go to solid, much colder temperature, and here is a block of ice. The molecules are still jiggling around, but less so than before. In this unit, we will be learning about fluids. By definition, a fluid is a substance that is capable of flowing and takes the shape of its container. Liquids and gases are both fluids. As you can see to the left, a fluid is made up of many tiny particles. Therefore, we can treat a fluid as a system of objects. The macroscopic properties of a fluid are determined by the properties and interactions of the particles that make up the fluid. There are four attributes of fluids that we will be investigating: mass, volume, density, and weight. There are also some assumptions we'll be making. For liquids, we will assume they are not evaporating and that they have a constant mass. They have a constant volume, which means they're not compressible. Therefore, they have uniform density throughout the entire liquid. And they take the shape of their container from the bottom up. Here are the assumptions about gases. They have a constant mass, so they're not leaking out of their container. They have a variable volume, which means they are compressible. They have variable density because they're compressible. They fill their container and therefore also take its shape. We will be investigating fluids in two main situations: fluid statics and fluid dynamics. Fluid statics, also known as hydrostatics, involves fluids that are at rest. Here are some examples: water sitting in a glass, helium trapped inside a balloon, a wooden log floating in a pool, a series of different liquids at rest in the same container, as shown here, a coin slowly sinking to the bottom of a jar filled with fluid, an air bubble rising to the surface of the ocean. Fluid dynamics, or hydrodynamics, concerns fluids that are flowing, like water traveling through a pipe. For the AP2 test, we will calculate what happens when pipes change diameter, or go up or down hills, or when fluids change speed, undergo pressure changes, etc. We will look at energy and mass conservation of flowing fluids.